Hi class, this is Mrs. Lyons. This video is going to show you how to draw covalent compounds, Lewis structures for compounds with double and triple bonds in them. So the first thing we need to do is we need to think about what do I mean when I say a double bond and a triple bond. Okay, we said a single bond is when two atoms share one pair of electrons. So it kind of follows that a double bond is when two pairs of electrons are shared. That would mean a total of 4 electrons. And a triple bond is when 3 pairs of electrons are shared, or 6 electrons. So let's just jump right in and look at some examples of how we draw these Lewis dot structures. It's a lot like our previous examples. Okay, CO2, carbon dioxide. Remember we said that the first atom, unless it's hydrogen, always goes in the middle. So carbon's going to go in the middle. I'm going to put an oxygen on either side. It doesn't really matter where you put them. If you put them on the top and bottom, you'd still get the same result. Okay, carbon is in group 14. Carbon has 4 valence electrons. Oxygen's in group 16. It's going to have 6 valence electrons. Okay, so let's draw in these 6 valence electrons on each oxygen. Now we need to draw some bonds. Okay, so if we look, the way we've done it in the past is we want all of these single electrons to pair up so that they're not alone, so that each atom has 8 valence electrons once it's all said and done and everybody's shared. Okay, now if we think about it, this makes sense. We would do this. This is what we've done with our single bonded compounds. We draw a bond, a loop between the carbon and the oxygen. But notice that I still have these single electrons hanging out. And if you count, our oxygen now has 2, 4, 6, 7 valence electrons. So it's not in its most stable form. What it's going to do is see these other 2 electrons that are still alone. Those electrons are going to be shared just the same as a single bond, only with 2 loops. We call that a double bond. So on this other side, notice we've still got this electron and this electron. Those 2 electrons, and I'm going to draw this really funky loop around here, are going to be shared. Okay, so let's neaten this up. Let's make a nice neat picture of what carbon dioxide would look like. Okay, everywhere we've got a loop is a bond. So I have 2 bonds to this oxygen and 2 bonds to this oxygen. Now don't forget, those lone pairs of electrons still need to go on each atom. This is what my molecule is going to look like. Now let's just check some things out. Okay, remember we said that every atom wants 8 valence electrons. So let's draw a box around. Okay, this oxygen has 2, 4, 6, 8 electrons once you count the ones it's sharing. This oxygen's the same. It's got 2, 4, 6, 8 valence electrons. So the oxygens are both completely, totally happy and stable. What about the carbon? If we draw the things that are bonded to the carbon, we look 2, 4, 6, 8. Carbon has 8 valence electrons. So our picture of carbon dioxide with 2 double bonds shows that we have the most stable arrangement of the atoms with this double bond. Okay, that's a double bond, and it is 4 electrons being shared between those 2 atoms. Let's look at another example. H2CO. This one looks a little scary. It's got hydrogens and carbon and oxygen. Remember we said hydrogen cannot be the central atom. So we're going to go to the next atom. That would be carbon. It's going to be our central atom. Then I've got 2 hydrogens and an oxygen. I'm just going to stick them around. I'm going to put a hydrogen, and an oxygen. Now I need to put in my valence electrons. Remember we said carbon has 4 valence electrons because it's in group 14. Oops. 1, 2, 3, 4. Hydrogen, each hydrogen only has 1 valence electron. And I'll put those on each hydrogen. And then oxygen's in group 16. So oxygen has a total of 6 valence electrons. Now, when we go to draw some bonds, this is easy. We know that hydrogen can only make one bond. Remember honk? Remember our honk rule? Hydrogens can only have one bond. Okay? How many bonds can oxygen have? Remember we said oxygen, HO, can have 2 bonds. So let's see. I could make a bond here and a bond here. Looks like I've got all of my single electrons taken care of and designated. Let's see how this would look if we draw this out. Instead of loops, we make nice, neat bonds. We've got this carbon in the middle. It's bonded to one hydrogen, and it's bonded with a single bond to another hydrogen. And then there are 2 bonds to an oxygen with 2 lone pairs of electrons. So this is our compound, H2CO, with all of its bonds, all of its atoms stable with 8 valence electrons each, except, take that back, hydrogen, remember, only needs 2. What about O2? This is oxygen. This is like in the air we breathe. It's O2. So let's think about this. There's not really a central atom in this because we've just got 2 atoms. We've got 2 oxygen atoms. They're both in group 16. So I'm going to draw 6 valence electrons around each of my oxygen atoms. And now I need to bond. Let's see what I've got to bond with. Well, this is easy. I've got a pair of electrons there that's alone, and I've got a pair of electrons there that's alone. So oxygen has 2 double bonds. So if I drew this out, it would be O, double bond O. Don't forget the lone pairs. We've got to make sure we get those in, otherwise it won't look like each atom has 8 electrons. So this is O2 with a double bond between the 2 oxygen atoms. Let's do a couple more. Oh, how about N2? This is nitrogen, the nitrogen that makes up 78% of the air we breathe. N2, again, no central atom, so we're just going to draw 2 nitrogens. Okay, nitrogen's in group 15, so it has 1, 2, 3, 4, 5 valence electrons on each nitrogen. Now remember the honk rule, H-O-N-C, H-O-N. How many bonds can nitrogen make? 3 bonds. So that should be a clue to us what's going to happen here. If we draw a bond here, we can draw a bond here. Okay, and then there's these odd electrons out on the outside, and I'm going to draw this big loopy bond to show that they're shared. Then we're going to neaten this thing up. We're going to make it look nice and neat. Each loop becomes a line. So we've got 1, 2, 3 loops, so 3 bonds. And then I'm going to draw my 2 lone pairs and draw them out here on the side. So this, what do you think this is? 3 bonds. That's a triple bond. How many electrons are in that triple bond? If you said 6, you're absolutely right. Let's just do this little exercise of circling the atoms. If we look at this nitrogen, 2, 4, 6, 8 valence electrons. If we look at this nitrogen, 2, 4, 6, 8 valence electrons. So both nitrogens are in their most happy, most stable state with 8 valence electrons. One more example. Let's see, we've got HCN. Remember, hydrogen can't be the central atom, so we're going to put carbon in the middle, hydrogen, nitrogen. We're going to draw our Lewis structures for our atoms. Carbon, group 14, has 4 valence electrons. Nitrogen, group 15, has 5 valence electrons. And hydrogen in group 1 has 1 valence electron. So we need to start figuring out where our bonds are going to go. Well, we know hydrogen can only make 1 bond, so that's that. And then if we look, we could make a bond between carbon and nitrogen. We could make another bond between carbon and nitrogen. finally, we could do this third very loopy bond. So now all of our electrons have a partner. They are all shared pairs. Now this one definitely needs neatened up because it's all messy with those squiggly lines. So let's see, carbon with a single bond to a hydrogen. And then for each loop, I'm going to draw a line. Don't forget the lone pair of electrons up here. So this is our Lewis dot structure for HCN. Let's do this little trick. If we circle the nitrogen, we have 2, 4, 6, 8 valence electrons. If we circle the carbon, we have 2, 4, 6, 8 valence electrons. And hydrogen has 2, which is all hydrogen needs. Okay, so hopefully this has given you guys an idea of how to draw Lewis dot structures with double and triple bonds. Hope this makes sense. We will talk about it in class. I will see you soon.